Okay, watch your step.
Okay, hi. I'm Siobhan. I'm one of the ketogenic forum admins, and I also occasionally post to cholesterolcode.com. And one of the things I wanted to talk about today was about lipoprotein-Little-a, which has come up a few times, I've noticed. Um, and I actually get questions about this quite frequently, actually. And it has gotten to the point where whenever Dave gets a question about it, he promptly sends them over to me. Thank you, Dave. So the most common question I actually get is, it's typically, I have high lipoprotein-Little-a. Do I need to worry? And thanks to Nick, I can quite confidently say, I don't know. But we can discuss what we do know. So first off is that what it is. Apolipoprotein-Little-a is attached to the ApoB particle on an LDL-like particle, purple boats. And that has a physical structure that, interestingly, is very similar to fibrinogen. Fibrinogen is used for wound healing and scar tissue, making scar tissue. And it looks like lipoprotein-Little-a does have similar functions. So those, plus a couple others like clotting. And it's a very interesting topic, so I have to sort through in my head. But one of the other interesting things about the APO, the tag on the lipoprotein particle, is that the physical structure of it actually determines a genetic baseline. So you can have higher or lower lipoprotein-Little-a levels based on genetic differences. And they actually did a study to look at some of those differences, and they found that for the two that they study, a higher lipoprotein-Little-a from those genetic factors actually did not increase mortality in people who already had heart disease. So there is one factor of having high lipoprotein-Little-a from genetic factors, but there's also a different context. And that context is that lipoprotein-Little-a has been found to work as an acute phase reactant. So what that means is that when something majorly bad happens, so a myocardial infarction, a stroke, or even severe infections, lipoprotein-Little-a will go up in response. So with that in mind, it actually makes sense that it is correlated with cardiovascular disease because, as we know, with cardiovascular disease, there is major damage going on. So now we have this interesting case of two very different system contexts for high lipoprotein-Little-a. We have a case where it's a static baseline based on genetic variability, but we also have a damage context. So one of the ways to sort out if lipoprotein-Little-a is an independent causal factor in heart disease is to try and separate that out by looking at inflammation markers or markers of oxidative damage, which has luckily been done. They actually did a couple markers, but I'm going to focus on Lp(PLA2), which, to extremely simplify, it basically removes damaged parts of the lipoprotein so they can be broken down and thrown in the rubbish. So what they found was that for high lipoprotein-Little-a and low Lp(PLA2), so that's low damage, or at least that type of damage, the hazard ratio was 1.12, which is nothing to write home about. Then we can compare it to high lipoprotein-Little-a and high Lp(PLA2), so high causes of high symptoms of oxidative damage, and the hazard ratio for that was 3.5, which is above 2, which is something to look at further, to say the least. So now we have these two contexts and separated out, and they have different outcomes, which is quite curious, I find, because I often see people saying that high lipoprotein-Little-a in itself is a causal factor, which, if were true, those would be far more similar, or at the very least, they would both be significant, but it doesn't appear to be true. So one of the things that I wanted to highlight for this is the danger of looking at markers in isolation. Because, as is true for many other markers, they can wear many hats. They can have many functions, many reasons for being high or low. We know this for LDL. It has roles in energy distribution, but also in immunological functions, which is what I tend to focus on. Across the board, this is true. So the fact that people are looking at markers in isolation and trying to draw conclusions for it is, in my view, insane. Not only that, but even the people researching lipoprotein-Little-a, they say in the studies, they describe it as mysterious, that the functions of the lipoprotein is poorly understood. We don't know a lot about it. We discovered it not too long ago, comparatively to some others, and we still have a lot to learn about it. So, with that in mind, I really want people to start thinking in different ways when it comes to the human body, because people have a tendency, as Nick pointed out, to think that it is a broken system from the start, that we create things to kill us, which, in my opinion, if the body is creating some of these lipoproteins to kill us, it's doing a very inefficient job. So, I will fully admit that I do not know everything about lipoprotein-Little-a. I will, in fact, be happy as we continue to learn about it, because I'm sure there's a lot we don't know, and as we continue to learn about it, I'm sure we'll find out that the functions it has will likely be far smarter and more efficient than anything we could ever design, because that is what I have found to be true, studying lipidology and the human body as a whole. So, yes, I'm done.
Thanks, Siobhan.